Hello everyone, welcome to the channel SRS. This is Sumit Roy and we'll study digital electronics, in that combinational logic, and in that full adder, parallel adder, or look ahead carry adder. As we have discussed serial adder in the earlier lecture, this is look ahead carry adder or parallel adder. There was a drawback. I'll start with the drawback of serial adder. There was a drawback of serial adder, that is means accumulation of delays are occurring. That is, this is first of all, this and this will work as a full adder circuit. As per this is the full adder circuit. As per full adder circuit, this will give us S0 and C1. This output will be utilized by this to give us S1 and C2. This C2 will be utilized by this to give us S2 and C3, and this C3 will be utilized by this to give us ultimately S3 and C out. And the whole thing is our total output. So actually, this is depending on this is depending on this, and this is depending on this and this and this. So there is obviously accumulation of delays that is occurring. It cannot work independently. It is dependent on this. So that is serial adder. That is the biggest drawback. That is, if 1 second in one instant, let it be 1 second, if 1 second is required by this circuit to perform, then first of all 1 second is required, then 1 second, then 1, and then 1, that is total 4 seconds will be elapsed to give us this output, because this is dependent. So in parallel adder, what we can do is, will not rely on this to give us C1, will develop another logic, altogether different logic, to give us C1, will generate it. Similarly, will not depend on this to give us C2, will generate C2. Will not depend on this to give us C3, will use another logic and will generate C3. So this is C1, C2, C3 generation. That is, we are not giving the output to this. Actually, we are looking ahead and we are generating this C1, C2 and C3 and giving it as input. So now at an instant only, there are available all three inputs. This is also having all three inputs. This is also having all three inputs. This is also having all three inputs. So at an instant, it can give the output. So that is the biggest asset in parallel adder. So now the question arises, that is how we can generate this C1. Actually, C1 is a function of A0, B0, Cin. That is it. This is C1. That is, if I'll write C, that is sum is also a function of A0 for this example, only this. Let it be S0, I'll write it in a more appropriate term. S0 is dependent on A0, B0 and Cin. And C1 is also dependent on A0, B0 and Cin. Okay. Second part, if this is concerned, then S1 is dependent on A1, B1 and C1. Okay. C2 is dependent on A1, B1 and C1. Now, as C1 is a function of A0, B0, so I can write, instead of C1, I can write A0, B0 and Cin. Similarly, this is also a function of A0, B0 and Cin. So, instead of depending on this to perform and gave us C1, C2, and this to perform to give us A1, B1, C1, and this will give us C2. So obviously C2 is dependent on what? A1, B1 and C1. Actually A0, B0 and Cin. So it is dependent on A1, B1, A0, B0 and Cin. So these things are already available. So why we have to wait for this to give us output? Why can't we develop this by our own? So that is what we'll do to get parallel adder. So I'll develop the circuit. I'll develop the mathematics, Boolean algebra for this. So let us see. And similarly for C3, similarly for C4. If I'll write for C3, it will be what? For C3, it's dependent on A2, B2 and C2. That is A1, B1 and A0, B0 and Cin. So all are available. So why we have to wait for this and this to perform to give us C2? So no, we'll not wait and we'll calculate C3, we'll develop another circuit and we'll develop C3. So that is what we'll do. So on this grounds, I'll develop the Boolean expression. So I've already written this Boolean expression full adder circuit, that is AI, BI gives and exclusive OR with Ci gives Si, that is sum, and this is this and this will give us carry. So this is obviously this is a known circuit. So I have write it down. That is Pi. I have named it Pi and Gi. So Pi is Ai exclusive OR with Bi. This is the output, and Gi is Ai dot Bi. So this is Gi. And based on this, I've written Si is Ai Bi exclusive OR with Ci. So Ai Bi exclusive OR with Ci. That is named as Pi. So Pi exclusive OR with Ci. So this is Si, and similarly Ci plus 1 is this is Gi, and Pi, and this is Pi, and this is Ci. So Pi Ci plus Gi, Pi Ci plus Gi is Ci plus 1. Whereas Gi is Ai Bi, so this is Ai Bi plus Ai exclusive OR with Bi exclusive and dot Ci. So this is Pi dot Ci. So this is what is Ci plus 1. So we are much more interested in the carry part. So I'll develop this Ci plus 1. I'll write it as Ai Bi plus Ai exclusive OR with Bi and Ci. So if I equal to let it be 0, so that we can develop C1. So it will be C1 is A1 B1 plus A1 exclusive OR with B1 exclusive OR with 0 is there, right? So A naught B naught A naught B naught and exclusive OR with C naught. So we are already having A naught B naught A naught B naught C naught. We are already having the number A, that is A naught, that is A3 A2 A1 A naught. We are already having the number B, that is B3 B2 B1 B naught. We are already having the number C in. We are relying on this. So if we are already having the numbers, so we can write this, we can develop C1. Similarly, if I equal to 1 is taken, that is C2. That is 1 plus 1 is C2 can be written as A1 B1 plus A1 exclusive OR with B1 and C1. C1 has already been developed. So why to write C1? I can write A naught B naught plus A naught exclusive OR with B naught and with that C naught. So this is, now look at it. C2 is a function of what? A1 B1 A1 B1 A naught B naught A naught B naught and C naught. All of them are what? All of them are already available. So why we have to wait for this to give us output? We can develop this circuit altogether by our own, and we can write here. So similarly for C3, if further is required, it's not required actually, but then also write it C3, that is I equal to 2. So if I equal to 2, then C3 is I equal to 2, that is A2 B2 plus A2 exclusive OR with B2 and with that is C2. Now C2, we have already written this C2, so again I'll completely reduce this part, that is I'll use C2 as A1 B1 plus A1 exclusive OR with B1 and A naught B naught plus A naught exclusive OR with B naught C naught, and this is it. Now look at the C3, that is, it is dependent on, it's a function of what? A2 B2 A1 B1 A naught B naught and C naught. So that is all. Means these are already available. Why we have to rely on this and this to give us C3? We can develop this circuit. A2 and B2 exclusive OR between A2 B2, ending between A1 B1 exclusive OR between A1 B1, ending between A naught B naught exclusive OR between A naught B naught, and ending between C naught. So we can develop the circuit. Why we have to rely on this? So we can develop this and this circuit by the help of this and this Boolean algebra and logic gates. We can develop this and this values, and now at an instant we can get it can give output, it can give, because they are already having the input. At an instant they can give output as S0, S1, S2, S3 and C out. So by this Yes, obviously this will be available, but this is not required, so it will be discarded. So this is the available value at an instant. Let it be 10 bits. At an instant only it can give the outcome. Obviously the circuitry will increase, but at an instant only it can give the output. So that is why, because all of them are working in parallel, so that is why it is also known as parallel adder or look ahead carry adder. The carries are not generated, they are looked ahead. That is why it is known as look ahead carry adder. So this is, I think so, will be all for this parallel adder. Till then, goodbye. Consider subscribing, and it will help the channel to grow. And like, comment, share. Comment if there is any doubt. I'll try to analyze and try to make a separate video for your doubts. If any questions are also there, I'll do some questions also. Till then, goodbye. Thank you.